In this video, we're going to look at some basic transformations of graphs. So we'll start by letting c be a positive number and y be equal to f of x. So the first few transformations we're going to look at involve vertical and horizontal shifts. The first one is f of x plus c. This means we shift up by c units. So we shift the graph of f up c units. Then we have f of x minus c. This one's down c units. And then f of x plus c. So we're adding c to the x. This one's, you think it's right, but no, it's backwards. It's left c units. And then the last one we're going to look at for now is minus c. So this is right c units. These feel backwards. That's how I memorize them. Whenever you add to the x, you think it's right, but no, it's left. Whenever you subtract from the x, you think it's left, but no, it's right. So it's a little bit backwards. Let's look at a bunch of simple examples. So let's say we had y equals x squared plus 3. So you want to think of this as your f of x, right? This is your f of x. And you're adding 3 to it. So x squared looks like this. It's a standard quadratic, right? This is the graph of x squared right here. This is x squared. And it starts at 0, 0. So basically we're adding 3, so we're taking each y value and shifting it up by 3. So we're taking the entire graph and going up by 3 units. So from 0, we just go up 3. 1, 2, 3. Then you put a dot, and then you just draw the u. That's it. That's this graph right here. Let's look at another example. Say we had f of x equals the square root of x plus 2. In this case, our base function or our core function is y equals the square root of x. So it looks like this. That's y equals the square root of x. And we're adding 2 to the x. So you think it's right, but no, it's left. So we take this whole picture and we just go left 2. And there it is. So this would be this function here. So in this case, we went up 3. In this case, we went left 2. Let's look at another example. We'll do it down over here. Say we have f of x equals the absolute value of x minus 2. In this case, our base function or our core function is the absolute value function, which looks like a v. And this means we're going down 2 because we're subtracting 2 from the entire function, right? So we just take this v, and from the middle we go down 2. So 1, 2, boom, and we draw the v. And that's it. Let's do maybe one more. Say we had f of x equals, I don't know, let's see, x plus 3, quantity squared. In this case, we were going left 3 because we're adding to the x, so it's backwards, and the base function or the core function is x squared. So we start with this one, and then we just take the whole graph and go left 3. So 1, 2, 3. And there's our u. Oh, one more. I'm going kind of fast, but it's good to see lots of examples. F of x equals, let's do square root of x minus 2. So in this case, you're subtracting from the x, so it's backwards, so it's right 2. So we take our square root function. There's our square root of x. And we take this entire graph and we go right 2. So 1, 2. Boom, there it is, and there's that graph there. So to recap what we've done, because we went kind of fast, so the first example here, x squared, that was our u, and we went up by 3. So we took the whole graph starting at 0, and we just went up by 3. We got our graph right there. Beautiful stuff. Okay. The next example was the square root function. When we add 2 to the x, it's backwards, so it's left 2. So we took our square root function, and we shifted it left by 2. And the next example we had was the absolute value of x minus 2. So we started with the absolute value of x. That was our core function. We subtracted 2 from the entire function, so we went down 2. The next example we had was x squared. We add to the x, so it's backwards, so it's left 3. So we took the whole picture, and we went left 3. And the last example we saw was another square root function. We subtracted from the 2, so it's backwards, so it's right 2. I hope that made sense.